transfer one block. Okay? Is that clear? Are these two steps clear? Step number 1 and 2. Whenever you want to convert from one number to another, you first divide by that number. So the first step is division, so that you get to 1 unit, 1 byte. And then you multiply by how many bytes you need. And do the same operation on the other side. So this is a standard way, we call it unitary method in mathematics. This is a standard way to convert from one point A to another. Okay? Okay, so remember this 5.12 millisecond. Let me clear the screen here. So I asked this question, what is the average time needed to read one sector from the disk at a random location? So we found out that it is 5.12 millisecond. Okay? Now I'm asking what is the transfer rate in this? So what is a rate? Transfer rate means something per second. So look, what I have is, what does 5.12 millisecond mean? What I have is 256 bytes will get transferred in 5.12 millisecond. Okay? That's what I know. Now, the question that I ask is, how much time will it take to transfer? I mean, in 1 second, how many bytes can I transfer? That's the question. Okay? So again, I will do the same thing. I will first make this, I will first divide by 5.12 millisecond, divided by 5.12 millisecond, so that I get on this side equal to 1 millisecond. Okay, so I converted it to 1. Now because I divided by 5.12, I will divide here also by 5.12. 256 divided by 5.12. That's how many bytes will transfer in 1 millisecond. And now I want 1 second, so I just multiply by 1000, because 1 millisecond, there are 1000 milliseconds in 1 second, right? So on this side also 256 divided by 5.12, multiply by 1000. On this side also I multiply by 1000. Okay? So this is my rate. Let's see what is my transfer rate. It is 256 multiplied by 1000 divided by 5.12. So this is 50. This comes out to be exactly 50,000 bytes. So which means the transfer rate is 50 kilobyte per second. That's my transfer rate in this case. Is that clear, or should I repeat this again?
No, clear.
No, not clear? Okay. So let me start again. No, not clear or clear?
Clear.
Clear? Okay, good. Otherwise I was going to repeat this again. I thought it's not clear. Okay, so very good. Okay, so let's do the next one. Let me clear the screen. Let's do this one. Now this is a different problem now. I still want the average time needed to read a random sector from the same track. But now it is from the same track. It's not here. It was from a random location, which means I have to move the head. Now it's on the same track, so I don't have to move the head. So what's the average delay? The average delay in general, average delay is seek time, right? Seek time multiplied by rotational delay multiplied by transfer time. Okay? Now in this case, because the head is on the same track, what will be seek time? The head is on the same track, so it does not have to move. So what is seek time? 0, exactly. So I don't need seek time now. Okay? So I have rotational delay, which was what we remember, this was 4.15 millisecond. Okay, we did that before. And transfer time was 0.256 millisecond. We also did this before, right?
Yeah.
So So then this comes out to be 1.0624 milliseconds. That's your average time, and now I can convert it into a transfer rate if I want to. The same way, I say 1.0624 millisecond is required to transfer to 56 bytes. Okay? So how many bytes will be transferred in 1 second? I first divide this by 1.0624. So that comes out to be equal to 1 millisecond. So here I also divide by 1.624. So this is the time needed in 1 millisecond, and then I multiply by 1000, because there are 1000 in 1 second. So 1000 millisecond in 1 second. So this is the total transfer time, which is what, let me do that, 256 divided by 1.0624, that's 240 multiplied by 1000, so that's 240,964 what bytes. So it's about 240 kilobyte per second. That's the rate. Okay? Now notice that the rate has increased. Previously in this problem the rate was 50 kilobyte per second. Okay? Now it has increased to 240 kilobyte per second. Why? Because we don't have to seek. The seek time is not included. So the transfer rate has increased. Understand? Oops. And now let's do the last part. What is the average time needed to read a sector which is next to the sector which I last read? Which means I want to read a sector, but the head is at the correct position and the plate is also at the correct position, because there is going to be no delay. The head is correctly positioned to read the sector. Right?
Yes.
Is that okay? Okay, so in general our time is seek time. Seek time multiplied by rotational delay multiplied by transfer time. Now in this case, does the head have to move or not? Yeah. Does the head have to move? So there is no seek time. Seek time is 0. And does the head have to wait for the plate to get into it? No. So there is no rotational delay. That's also 0. Okay? So the only thing which is left is transfer time. And the transfer time we know is the transfer rate. The transfer rate is 1 MB per second. Okay? And the transfer time is 0.25 time. The transfer time is 0.256 millisecond per sector. Okay, so this is the transfer time and this is the transfer. Okay? So, any questions on this? So notice how the rate increased. The rate was 50 kilobyte per second here. It came out to be, what was it here? 240 kilobyte per second. And now in this case it is 1 megabyte per second. Okay? So this tells us that the disk access gets faster and faster if you are reading closer and closer to them. The head does not have to move and the disk does not have to rotate. Okay?
Yeah.
Any questions on this? Okay, so let's do another problem. What is the advantage and disadvantages of storing maximum 1 record per sector and storing records successively in sectors? Okay, so these are two schemes that we did. What is the advantage of this method? What is the disadvantage of this method? Does anyone know? Okay, so what does it mean, one record per sector? If I have this as one sector and this as one sector and this as one sector, okay? Now I have a record which is small, so the record takes only this space, but I will not use this space, I will leave it empty, and then the record will take this space, and I will leave this empty, and then the record will take this space, right? This is the first scheme. In the second scheme, I have this sector, then this sector, and this sector. Okay, I will save the first record here, and then the next record here, and then the next record here. I will keep saving them contiguously. Okay, so the advantage of the first is that I do not need to access two blocks, two sectors for one record. Okay, this makes it fast. This makes it fast because I exactly know where to go. I do not have to read over two sectors. Okay, this is the advantage. What is the disadvantage of this scheme? What is the disadvantage of this scheme? What is not good about this scheme? Anything? It leads to internal fragmentation. Okay, internal fragmentation means there are data and then there is empty space. There is lots of empty space scattered on your disk. The disk is not being fully utilized. Okay? Alright?
Yes.
Okay. And in this scheme, the advantage is, in the second scheme, the advantage is that there is no internal fragmentation, no fragmentation. But the disadvantage is that I might have to read two sectors for one block. Okay. What is internal fragmentation? I've already said this. When you have empty wasted spaces built into the disk, that's internal fragmentation. It's not a good thing to have because you are wasting it. Okay. All right. Question number 7. What is the difference between block organization and sector organization, cluster organization? I already said this. Cluster have fixed size of sectors, fixed number of sectors. Blocks are variable number of sectors, right? So, blocks are variable sectors, whereas clusters are fixed. Alright, what are subblocks needed to in the block organization? I mean, why do we need subblocks? So you need to put a start block which has the count. It's called a count block, which has to tell how big this block will be. Otherwise, how will we know which data belongs to one block? Okay, and you also put like a data parity check or some sort of control block, which tells some property of the data. Where will it end, for example, or what's the checksum of it, something like that. Okay? And this is called non-data overhead. You have to put non-data blocks inside to explain what the blocks are. So blocks is good because it doesn't lead to any internal fragmentation, but it has to have a non-data overhead. Okay?
Yeah.
Alright. Okay, next question. Okay, so this is from files. I have a C++ program. In fact, I should have another command here because the code is different. Let me add here hash include. Because I want to do a C out or a C in, it should have here IO string. Okay. Alright, now I have this program int main fstreamf fopen myfile.txt ios, so I'm reading from myfile.txt. Now write the code to read the entire file line by line and display it on the screen, then close the file. Okay? So what should I write here? What is the first line I should write here? Any idea?
On fire.
Oh, sorry, what?
My file. Then
My file. No, my file is already associated with the variable left now. This is your logical file name. So in the rest of the code, you will use logical file name. Because through this command of open, you have linked the logical file name to the physical file name. Right? Okay, so the first thing I can do, let's take the code. Okay, the first thing that I can do in the code is, a good practice is I can check whether the file is opened successfully or not. So I can say if f dot is open,